All right, so the last lesson's on the trapezoidal rule. It's really the best approximation. It's a whole lot better than RAM, um, the rectangular one. So think about. Um, let me do this a little. You can actually see the trapezoids in this picture, but what I want you to kind of understand, if we kind of make our little whatever here, and we do our little subintervals. When we do a trapezoid, we get a whole lot closer to the curve, so it's a better approximation. Um, Hopefully, you can hear me. My voice is shot. So, um, think of this as your x1, x2, x3, x4. So our change in x, say, is the same. So our change in x represents the width. The other thing is your trapezoid area, h over 2 times base 1 plus base 2. What I want you to think about is that if I do the area of this trapezoid here, this x2 is the base 1. So it'd be like, so this first trapezoid, if we find the area, I'm going to take whatever that change in x is times this y value here plus this y value here. Then when I go to the second trapezoid, this one here, that area is still going to be the change in x, but now we have this x2, we find our y height plus y3 here. This height is both base 1 for this trapezoid, and it's also base 2. I said that backwards. This is base 2 for this one, and then base 1 for this one. So all of them in the middle overlap. There's always going to be an overlap, and it leads us into the formula where we only use one of the outside bases, but we use 2 of all the middles because it's both base 1 and base 2 inside the shaded area. And it ends up being just an average of LRAM plus RRAM. All right, so for example, if we look at this, n equals 4 of x squared. So if we look here, our change in x is a fourth, right? So if we think about the formula, we're always going to take h over 2, base 1 plus base 2. So to use the trapezoidal rule, our h is just the change in x, which is a fourth. What happens if I take 1/4 divided by 2? That's 1/8. Then I need this base 1. So if I plug 1 into x squared, I get 1. Plus, I'm going to double my middle because this trapezoid here, this 5/4, which I plug into x squared, I get 25/16. This is base 1. I keep doing that. This is base 2. This is base 1. This is base 2. When I move to the second trapezoid, this is doubling up as base 1 for the next one. So I always have 2 of the insides, 25/16, plus 2, plug in 6/4, 36/16, plus, I'm running out of room, sorry, double up because this one's still in the middle, 49/16, plus, and then when you get to the end, we only use this one once, 4, plug in 2 to get 2 squared is 4. All right, then we add up all the middle, and our trapezoidal rule gives us 1/8 times, when you add the insides, you get 75/4, or 75/32 total. So just like with LRAM, you use the first one and not the last. With RRAM, you use the last one but not the first. With TRAM, you use one of the outsides and you double the middles. That's the key. And so you do the same thing with a table. So if we look at our change in X, our change in X is 1. So for the trapezoidal rule, I do 1 over the base over 2, h over 2, times, I use one of each of the outside values here, 63 plus, but I double all the middles. 2 times 65, 2 times 66. I'm not going to write them all out, dot, dot, dot. I'm going to do 2 times 58 plus 55, only one of the outsides, but double the middle. If you multiply all this out and add them up and take half, you should get 7/82. All right, so, but think about this, be careful. So this is the trapezoidal rule. It's finding, this would be the area underneath the curve. This wants us to find the average. It doesn't actually say. It should have a question in here that says, what would the average temperature be? Well, guess what? This is not the average temperature. So the average temperature is finding your average value. So we're going to do 1 over b minus a times the area, which we just estimated using our trapezoidal rule. So we're going from noon to midnight. So that's 12 hours times the area, which is 782. So our average temp is 1/12 times 782. So it's about 65.17. So notice this is within this range of temperatures. So that's our final answer. Sorry I'm gone. I wish I were feeling better.